Hello everybody, this is Bilal again with Hiba Learning Academy, and in this lecture we are going to continue uh, discussing the career path for IT professionals. This is the third video in the series of videos that I'm putting out there. If you haven't watched the first or the second part of this video, uh, you can find a link in the description. Please go ahead and watch those sessions first, so it will make more sense to you that what we're talking about here. So in the previous videos, we spoke about setting career goals and the two different types of jobs that you should be targeting. And the first group was the technical, and the second is the managerial. Now today we're going to talk about software engineering, the very first subject here, and the majority of my videos would be circled around software engineering. So I'll be putting out more videos in the coming days, tutorials for fundamentals of software engineering and how what things the users need to know before you jump to the next class. Um, So here is a diagram of what it involves when you write code. What happens? What things do you need to know, or somehow you need to understand before we write code? And like I mentioned, I have more videos coming. But basically, the way I would teach a person would be I would start with basics of what makes a computer. So the actual hardware, the physical parts that make a computer, there is a memory, there is a control unit, there is a processing unit, and then there is the storage. So we will talk about those in detail. Then we go one step higher, where we will learn how do we actually control the hardware. And for that, there's something called binary language. And this would be a very brief introduction because binary is kind of difficult to understand for human beings. This is a machine language. However, when I went to college, we had to take a class and exam for this, so I can show you guys basic operations of binary, how it works, what it does, and just basic stuff. We won't be able, human beings won't be able to understand anything that's complicated in binary. Now above binary, since this is not easy to understand, there's another language called assembly language, which is a little easier to understand, and it's a very simple language. So assembly language, you would need to know something about the assembly language. At least you should know what it is and how it works. And usually assembly language is more for folks who want to do chip programming and hardware programming. And the folks who work on this area, they would need to have very extended knowledge about the hardware itself that they're working. So this is a step up above binary language, but still this is a very simple language, meaning that doing a lot of complicated things and creating a program that has many modules and things of that nature, it's not that easy. And for that reason, the different programming languages exist, which sit somewhat on top of this, but not necessarily. So not every programming language translates to assembly language. Some do, some don't. But programming language are designed to be understandable by human beings, and the way, and there is different families of programming languages. For example, C and C++ and Java, these are kind of similar. The basic one is C. And then there are other languages which we will talk in details if you sign up with my class. So programming languages are easy to understand by human beings, and when we finish programming, when you compile them, the compiler that compiles the program into machine code, it can do one of two things. It could do either uh, a direct compile to binary, then it will be called a regular compiler, or it could compile to assembly, and it will be called assembler. Now, this is how you create software. You use a programming language to create software, and it's not just writing code. It's so many other things involved to create successful software. Going to my next slide. This is similar to what we just discussed, but this is actually the learning path. And like I said, my classes are coming. I will have some videos on YouTube, but to learn all the details of these different topics, my class would be in Udemy. It's not going to be very expensive. It's just out there to reach out more people. And the reason I'm putting out these classes is because I was searching for fundamentals of software engineering and programming class for a friend, and I didn't find any series or any class that was helpful and cohesive, where the student understand, start from basics and going to the advanced, where things are connected together, where once you work on one thing, then it will click. Okay, I learned this in previous classes. Anyway, so this is a flow of how would somebody go about learning computer programming. You can go ahead and start learning coding, but my recommendation would be, from my experience, I have 10 plus years of experience working as a software engineer and with different companies. I work for IBM, I work for other companies such as Cognizant, and I also work with different retail companies, such as Walmart and Kohl's and some other ones. I have very extensive experience in programming, and from my experience, for anyone who wants to learn, it always helps to have some background information on what you're learning. So for anyone who wants to learn coding, you would have to follow somewhat of a learning path similar to this. Now, this is for anyone who wants to learn Java and object-oriented programming. You don't necessarily have to follow this path, but with this diagram, I try to cover most of the things that you would need to know. If you follow this path, like I said, I have classes or videos coming in the next couple of days. We will start with basics of a computer. Like mentioned earlier, that would be what makes a computer. Then we will go over some examples of binary and assembly. This will not be very deep, very detailed. This would be very quick overview of what assembly language is and what binary language is and what they do, how they are related, just to give the student a chance to kind of connect the dots together. What happens when you type something in a keyboard? What happens behind the scene? How does the hardware work? Then we'll move on to fundamentals of programming. And this is something where you will actually learn what programming languages have in common. Every programming language have things that are very common. Once you master one of those languages, then you would be able to go open a book, go through some tutorials of a different language, and in a few days you can master that other language. When I started with IBM, I was a Java developer and a C# developer, and I didn't have a lot of experience with Java, but C# is somewhat similar. So I didn't have any problem starting with Java, but all of a sudden we started working on this project where it involved working on user interfaces, UI, HTML and JavaScript. And JavaScript it's a different type of language. Approach to things are a little different, but after a couple of days of going through the code and see how everybody else was coding, I became very comfortable with it, where came to a point where everybody was asking me. Of course, this was a couple of years ago, about 8, 9 years ago. Anyway, so this is an example of learning the fundamentals of any language. Before you actually write coding, there is something called algorithms, where you just think in programming concepts. What is it that you would a program does, and how do you approach it? And we will start with C, because C is a simple program. It's easy to demonstrate the fundamentals of programming. From there, we will go with object-oriented programming. This is a little advanced topic, and for this we will start with Java, and then we will learn database concepts. We'll learn some database operations and sequential query language, communicating with database. And then we move on to advanced programming. We will learn JDBC, how to connect to database. Then we will use Java graphical user interface to create an interface to. This is more of a practice project where we will we will create something that is similar to a real life project. We will have a review, and of course between each one of these modules we will have tests, we will have quizzes, and practice things. Now after we do a review and create another project, we will do it together. There are other things that you could be learning on site. You don't have to take my class, or you don't have to follow this way, but these 4 other things are somewhat necessary for anyone who wants to become a successful developer. You would learn how to work with different teams and manage your codes, merge your codes together, work in the same module where hundreds of other files are involved, and how you don't overwrite each other's code, and how at any given time everybody has the same code base. So this is very important. Code repository. Also, concept of quality assurance, QA. This is also very important. Quality assurance is like a very important building block of any software engineering. Without quality assurance, there will be no software. Without quality assurance, nothing will work. So the folks on QA team, their job is to make sure things are done the right way, things are done based on specs, and things are done based on what the client wants. So the developers don't waste their time and misunderstand things, and continue working where you come to a point that you have lost so many hours and time doing the wrong thing. That's where quality assurance come into play. And the second module is kind of similar like that, but this is more like a little more detailed explanation of quality assurance, how defect resolution works. Working together with quality assurance team, with QA team, is very important. You need to learn how to work with this other team, and you need to learn how to put them in, let them know anything that happens in the code, any major decision that you need to take. You need to let these folks know that there is a change in the plan, and this is how it needs to be tested, and if it's okay with them, then you can do it. The last thing we would learn is the SDLC, software design, the software design development lifecycle, and this is also very important. And we will talk about it in the next lecture in more details, but basically software development lifecycle is something that every developer needs to know. And this is more for project managers. They will need to know more and detailed, details about all of the different schools of thought and software development lifecycle. But as a developer, you definitely need to know more about it. So this is all I have for this lecture. Next, we will talk about the other topics that we discussed. So until then, I'll see you guys in the next lecture. Bye.